We going? We're moving. Okay. So in class earlier on, I said this graph, the graph that you get for the internal resistance, is not anyway at all contradictory to this graph that you get for a fixed resistor, although on the face of it, they're totally contradicting things. I said, right guys, it's the same physics and it all applies in the same circuit. I said, set up this circuit, let's make the EMF always 4, let's make the internal resistance, it can't change, always 1, and let's just change the resistances. So I had a 7 ohm resistor, a 3 ohm resistor and a 1 ohm resistor. I can obviously calculate the current in the circuit by just dividing the EMF by the total resistance. So here the resistance is going to be, or the total current is going to be 0.5 because it's going to be 4 divided by 8, the total resistance. Here the total current is going to be 1, and here the total current is going to be 2. Now I can easily figure out my lost volts. My lost volts are just this resistance multiplied by the current that's going through it. So I just multiply this number by the internal resistance, but I've made it very easy for myself. It's just going to be the same number, so it's going to be 1.5 volts, not amps. 1.5 volts I'm losing there, and I'm losing 2 volts there. And over here, my terminal PD, so what is the actual voltage across this resistor going to be? Well, it's just going to be the EMF minus the lost volts, isn't it? So it's going to be 3.5, it's going to be 3, and it's going to be 2. And so if we now plot the terminal PD against the current in the circuit, what you see is, so when you've got a high terminal PD, you've got, which one am I plotting now? Terminal PD against current. I'm getting high terminal PD, low current. Yeah, I'm getting this graph here, aren't I? High, yeah. And then I said, and of course, because it's all the same physics, you have to generate this graph here. And then I looked at it, and I got confused, because when I was looking at terminal PD, I could see that was going down, but I could see the currents are going up. So when the voltages are going down, the currents are going up. And I got very confused. Can you not tell me what my mistake is? What is my mistake? Why is the physics breaking? Physics is breaking because I'm changing the resistance all the time. I forgot. This graph is for a fixed resistor. I just can't come along and change the resistor all the time. So a better way of sort of looking that these two graphs belong to the same universe and the same physics is to set up a circuit like this. So what I'm going to do is I'm going to close the switches one after each other. This way the voltage across the resistor is just going to be the terminal PD, but I'm going to change the current through the battery. I'm going to lose my volts still, but I'm going to get the current split in here. So let's see. Well, I've only got one switch closed, so let's close one switch. Good, that's closed. My internal resistance is 1. I've set each resistor to be 3 ohms. So the total current in the circuit is going to be, well, the total resistance is 4, so it's going to be 1 amp. And then what I'm going to get is my lost volts. My lost volts is going to be my current times my internal resistance, which is 1. And my terminal PD then should be 3. Here's where I should have done my maths ahead of time. So, now the total current, what's going to happen now? Well, my resistance now is 1.5. The total resistance is 1.5 when I close this, because I'm going to use this equation here. So it's going to be 1 over 3 plus 1 over 3 is 2 over 3. Flip it upside down, I get 1.5. So I get 1.5 plus, so my total resistance is not 3, my total resistance now is, external resistance is 1.5, plus 1 is 2.5, so the current is going to be 4 over 2.5. Someone can check that out to me in a second. So my lost volts is going to be my current times my resistance, which is 4 over 2.5, and my terminal PD is going to be this minus this, which someone can check out for me. Now, what's the peak terminal PD? 2.4. Now, here, what's going to happen is I close the last switch, and it's going to be 1 over 3 plus 1 over 3 plus 1 over 3 plus 3 over 3. So the total resistance is 1. That's the external resistance. The total resistance in the circuit is going to be 2. So the current is going to be 4 over 2, which is 2 amps, total current in the circuit. So my lost volts is now going to be 2 times 1, which is 2. And now my terminal PD is going to be 4 minus 2, which is 2. So, what do I have here? Let's see what's happening. I should have said that the current in each branch. If I know this is the total current in the circuit, what's going to happen to the current in each branch? Well, the current in each branch here at the start is just going to be the same. It's going to be 1. Isn't it? The current in each branch now is going to be half, because I've got 2 things on, it has to be half of this value here. I need a calculator.
0.8.
What?
0.8.
0.8. And the current in each branch is going to be this divided by 3, so it's 2 over 3. Physics has to work now. Current in each branch. So, if I now do it, I hope I've got it right after all this. Let's do the internal resistance graph. So that's going to be the terminal PD versus the current in the entire circuit. That's going to be, this is going down, so the voltage is going down as the current's going up. Yeah? Yes. Terminal PD is, so we're getting this graph here. This graph is definitely existing. What is happening to the current through any given resistor with the voltage? So what's happening is, you can see my terminal PD is going down, so I'm changing the voltage across it. The voltage here is decreasing. The current through each one is decreasing. Physics works. Physics is fine. It was just me earlier on, was a little bit broken. Boom. Oh, by the way, I've done an Excel spreadsheet which you can check out in Firefly. Finished.